Okay, guys. So today is March 22nd. We've successfully completed part 1. So today, let's do the part 2. Okay. So last time, we've seen a Toka listener example after installing ROS2. So today we are going to create a custom publisher subscriber package. Okay, since you are new to ROS, do you know what publisher subscriber? Kind of? Okay.
Maybe the person who publishes the node, the people who use the node.
Yeah, it's about like a topic.
I see what you're saying. Yeah.
Yes, subscriber, publisher, they talk each other through message. Okay, that message will be controlled by based on topic. So I mean, if you have a rough idea, at least like a publisher subscriber, we will learn by doing. Okay, so I mean, I don't want to go back like ROS1, all the stuff. Okay, so okay, step 1, creating custom Toka listener package. Let's see. Oh, by the way, I want to explain this terminal. This is a special terminal, which is called Terminator. Interesting name. The default terminal, you have to open many as we've seen last week. We have to start a new terminal to start a new subscriber. We have to have a separate terminal to start publisher. If you need one more subscriber, we have to start another terminal. So after a while, you will see a lot of terminals overlapped and really hard to find where I should go. Okay. So this terminator has a very convenient way to create multiple terminals in one big terminal. Okay, so this is one popular way, especially where we need a lot of terminals running at the same time. Okay, this is terminator. So this is not part of a Ubuntu standard package, so you have to go so Terminator Linux terminal emulator with multiple terminals. Okay, this is my terminal. Okay, your default terminal does not look like this, but very convenient tool for your ROS. Okay, so here first thing you gotta do is create our workspace called ROS2 _WS. Okay, that means is by the way, some of you are new to Linux, so this tilde, that stands for your home. Okay, wherever you are, I can do this. That means home Jaerock, that's my home. Okay, even this is same as home Jaerock, also same as just CD. If you don't specify anything, that means I want to go back to my home. Okay, so do you see this mark there? Okay, that means I am at, that is my current folder or working directory. Okay, So I can change, like for example, like here, then this shows me tilde / document. That means I am at home Jaerock documents. Okay, so that makes this sense. Tilde meaning under my home, create ROS2 folder. Okay, and then another folder. So two folders. If I do this, create mkdir is a command, make directory. If I do, since I am at my home, okay, I don't need to even do this, okay, because I am that location now. So I can do this, okay. This will work, but this is not gonna work because you cannot create a new folder inside that new folder and create. This is what you are asking is, I want to create ROS2 WS and then create SRC. Okay, this is not work. So that is why we put this P. Okay, this means if I give a multiple steps directory, create all those directory in that sequence. Okay, so if I do this, this will create. I'm gonna use a visualization as well here under my home. I just created ROS2 workspace. Under ROS2 workspace, I have SRC. Okay, good.
So wait, where do you go? Each one setting?
Setting? Which one?
To pull that gray screen right there, the one with the SRC.
This one?
How did you find keys? How do you find like the directories? Like where you just found to like see the folders like that?
Yeah, like the folder right there.
Is that why you created?
I just created.
Like literally, I think you mean it was like in Linux. Where
Yeah,
did you
like-
go to find that folder?
Like the gray tab right there that you have.
Great tab.
Yeah, right there.
This one?
Yeah, how'd you get there? You
Oh.
just-
Oh, okay. I'm using a different GUI. Okay, but you have this one. This is a name files. Okay. If you open files, I think you have something like this, right?
What do you get?
Yep.
Oh, there it is.
Yeah, I have some slightly different user interface. Okay.
Thank you.
Yep, no problem. This is files, okay? Just intuitive name, files. Okay. If you want to stay this one here, okay, then just, for example, like here, I could remove from favorite, then, okay, how can I start that files? Then you can just start from, like, I click the Windows button. If you are using Mac, that's the Mac button. There's a special key. You can type anything, then I can search files. This is my file explorer. I have this. If you want to keep this one, right click, add to favorite. That will be in here. So I'm using this. So I just place, okay. And another shortcut for terminal is terminal T, Control Alt T. That is a shortcut for terminal. So I can start by just pressing Control Alt T. Okay. So files under home, we just create a ROS2 and SRC. Empty. Okay. Then build the workspace. So the ROS workspace has SRC folder. You must have that SRC folder under your workspace. This workspace is nothing special. This is just a normal folder. Okay, you don't have to have underscore ws in the folder name. Doesn't matter. I can make like Superman. Doesn't matter. Okay, but this is just a convention. By having this underscore ws, that indicates, okay, this is a folder for ROS. Okay, so yeah. So then now I can change my current working directory to inside the workspace. As the name implies, workspace, right? You should be there most likely in order to do something. That's your workspace. Then colcon, C-O-L-C-O-N, and then build. Colcon build successful. Summary 0 package, finish it, because I don't have anything here. Okay, empty. But at least this shows us colcon is working. Okay, then what is colcon? So it's an iteration on the ROS build tool. Catkin make, isolate, catkin tool, amend tool. You don't have to know. Just colcon is, you have a package you want to build, then just do the colcon. Okay. So these are already installed. We don't have to install anything. Okay. Don't worry about this. Question? Okay, cool. So colcon build. So we see this. We are good. Create a new Toka package. Let's use a Python for simplicity. So again, now we are at my home ROS2 workspace. So we don't have to cd do this because we are at right there. And then I'm creating a package ROS2 pkg create, and then build type amend python toka underscore listener. That means I'm creating a package. Package name is Toka listener. Inside this ROS2 ws. So it creates all the necessary folders. I can use this one again. Under the src, nothing, because I didn't do anything yet. But after create pkg, I have build install log Toka listener. And if you go to Toka listener package, there are something setup.py, setup.cfg, and package.xml, and resources Toka listener test. Don't worry about this for now. So we got this. We are successful. And then navigate to the code directory, which is your code will be under the source Toka listener. Okay. So here src, nothing. Which means we have to create, right? It doesn't imply it has the package to navigate to the code directory. So we gotta create new folder using these files, or I can go to here, cd src, and then mkdir Toka listener, and then Toka listener, Toka listener. Okay. and go to Toka listener. Again, use the tab auto completion. So now we are at here. Okay. Okay, and then make the Toka node, and then we have a gedit. Gedit is a text notebook, notepad Windows. Gedit is a text editor. That's a very basic editor. I don't like that one, so I'm recommending I think it's the code. Let's see. Visual Studio Code. This is an open source project from Microsoft. It's a multi-platform. It supports Windows, Mac, and Linux as well. So I think the code. This was name is the VS Code. No, just Code. Yes, just Code. Okay, Visual Studio Code. So I recommend this as your IDE, and I can open folder, which is my home and ROS2 workspace, and then click OK. Trust the author. Then ROS2 workspace, build, install, log, src, Toka listener. Okay, underscore Toka listener, right? We can create a file inside here because we want to do something that is Toka underscore node dot py. So this one. Select a language to get started. Python. Okay, that is my Python. And this is code that we need to complete. I don't want to type everything here, so I can just copy and paste. If you are learning new language, don't do this. Okay, type every single line. That is the best way to learn a new language. Okay, because that makes that means you will make some mistake here and there. By trying to fix those mistakes, you will learn much more. Okay. I got everything. Let me explain line by line. For now, I'm gonna change the file name, save to Toka listener. No, under src under Toka here, right there. The name was Toka node. Oops. Go here. Toka node.py. Okay, now see. So under the source Toka node, Toka listener, I have a Toka node. Cool. And Python. Do you guys know Python?
A little.
Okay. It's basically just include these packages. So I import RCLPy, that's a ROS client library for Python. And RCLPy node import node, which means I will use this node and I will use this string. Okay, so node, I can see here, minimal publisher. Node is the input, that's a class, C++, right? Same thing, this init is a constructor. So super init means super class, parent class, initializer, super class, constructor with the name minimal publisher. And then self is necessary for Python class. Self means this in C++. So publisher, I am creating a member variable named publisher underscore with using a create publisher. This topic type, message type is a string. Okay, and then timer period 0.5, and then create a timer. So self dot, this timer underscore period doesn't have self dot, right? Meaning this timer underscore period is not a class member variable. Okay, this is just a do you guys know the auto variable in C++? Like no, global means that will stay, auto means it will be on the stack, so after the function the variable will be gone. That's the when you don't have self here, that means this only available inside this particular function. So underscore init underscore, that's the constructor special name. You got to have this exact same name. So this temporary variable 0.5, because this is only available inside here, you don't have to create, but that just for the readability, I can 0.5 means okay, that's timer period again. So this publisher, timer, and I can be accessed inside this class, okay, because that's class member variable. And timer callback, which is here, meaning every half second this timer callback will be invoked by the timer. Do you get it, right? So every 0.5 seconds this timer callback will be executed. We construct a message, hello world %d, and self.i. I was initialized by 0, so initially hello world 0, and then publisher, which was created here, and publish with this message. So this topic is published with this message. Message is string type, then string is hello world : 0. And then this is just a logger. Logger is a logging stuff, so don't worry about this. And +1 plus equal 1 means just add 1, increment by 1. So I can tell every single half second you will have hello world 0, hello world 1, hello world 2, hello world 3. So keep this message is publishing, this topic is publishing. Okay, so this minimum publisher, one class, I can create that class instance. So minimal underscore publisher is an instance of this class, and then RCLPy, again this is ROS client library for Python. Spin means, as name implies, spin means doing something. Okay, with this minimal publisher, if you read this code, main has a RCLPY spin and minimal publisher destroy node and RCL shutdown. If this spin doesn't do anything special, holding the program keep running, your program will, this program will be shut down right after this, right? This spin means you may consider this as like a loop inside. So you start this RCLPY.spin unless any error happening inside. It's an infinite loop basically, okay? Just keep running inside here. So, and DEF main, unlike C, this DEF main is not a special function, okay? Making this function special is this part. If underscore main, underscore name, underscore equal port, underscore main, underscore, okay. What this is, when I run this Toka node.py from terminal, okay, then this equality makes sense. When I start this program from the terminal by typing Python Toka node.py, then this if statement is true, okay. Then this is the starting point. Okay, don't be confused with like a C or C++. I can use like this one, even like Jaerock, and this one is.
So what would be an example if that if statement was false? Like how, like why would it be false?
This Python code can be used by some other Python code. Okay, if you import this Toka node.py, it doesn't start anything
because it's being used for something else. So it
because
doesn't
these are just a class and function. Unless I call it, it doesn't do anything.
Oh, I see.
Okay? If we don't have this one, and then you
it's
type,
like a source file to be used for something else.
yeah, if I have this way, and then I tried Python and then Toka node.py, doesn't do anything because I have just a class, I have just a function. Function is, yeah, exactly. So I can call definitely just like this. Then this will call this function, okay? But in this case, somehow, some way, I need to import this Toka node.py from other Python code. This Jaerock will be run. That's not what I want, right? That is why we have this special code guaranteed when this function, Python code is running from terminal, I want to start from here. Other than that, no function will be automatically called, okay? Shoot. Make sense? So we created a simple publisher making us message hello world 0 1 2 3 every half second. That is a published as a topic, okay? That is what just we did.
So when do we get to the terminating condition?
There is no terminating condition here.
Okay, so it's going to keep on running forever?
Yeah, forever, unless you stop
Stop what?
stop this program.
Like turn off the computer or close it down?
Turn off,
Exit the command.
yeah, turn off all your command or terminal here. If something is running, for example, like let's say gedit, I started my the okay, this is text editor. This is still running, right? Okay, I wanna stop this one. Control C, Control key and C. That means, hey, I wanna stop it. Same thing for ROS node. If you wanna stop, Control C, then that will kill your ROS node. Okay. Then back to this code. Not that one. I got this VS Code here. If I press Control C, then this spin will be ended, and then destroy node, and then RCL PY shutdown, and program ends. Okay. Then now, take a look at this. Okay, I don't want to just repeat this. Here, just important concept is RCL spin is blocking. It was non-blocking ROS5. Blocking, non-blocking. If you are from like a CS, blocking means what? Synchronous. If you have an infinite loop and doing something there, then you are not gonna getting out from there, right? Non-blocking means since you are doing something inside blocking area, your program cannot do any other things, right? Non-blocking means I'd like to have some kind of looping condition, but in the meantime, I want to do some other things. That is concept of non-blocking.
So like allows finite objects to happen infinitely, which is why you can do stuff in between.
Other system needs to have chance to do something. Okay, so here spinning blocking means if this is running, at least this particular Python code cannot do any other things. But Ubuntu or Linux, this is multi-processor system running. You can start other program.
Did you do that in ROS1?
ROS1.
Oh wait, never mind.
According to this statement, it didn't do in ROS1. ROS pi is a ROS1 in this case. So it was not blocking. ROS1 also has a spin. So it says it was not blocking. Blocking in ROS CPP, that's a C++ version. To us, it doesn't do anything. Okay, we gotta have spin anyway, otherwise your program is not running. Okay, because it makes your program keep running. Your ROS node keep running. If I don't spin, it will publish maybe once and then program ends. Okay. Okay, then that is it for Toka node. And add dependencies. Navigate back to find packages.xml, which is under the Toka listener. Still, I'm at the ROS2 WS folder, and then package.xml. This is an information file about this package. So as you can see, I see version, I see name, and I see copyright, and I see a package description. So I can do like email. I have, that's my old email, and I can see It's something like that. Okay, why we have to have this when this package is like open source available for other guys? Then they will figure this out, how they use this package and who create. If something wrong, I have to I can contact this guy. Okay, hey, I tried this and this is not working, or something like that. Okay, so here license declaration, we can put something. This is open source license or any other license. But more importantly, we have to. They are all optional. We don't have to have those, but we got to have these two. EXEC depend. Okay, EXEC depend, meaning under navigate back to find this at the following lines, which means this package format 3, that's the root node. I need to add these two in the root node. RCR-Pi, ROS client library Pi, and std-msgs. That's a standard message that is for this. Okay, string is part of standard message, so we have to have standard MSG and RCLPY. Okay, this execution depends on RCR-Pi. This execution depends on std-msg. Okay, that is a dependencies concept. Then an entry point, setup.batch. This is new to ROS2. We didn't have this one for ROS1. Okay, save it. And then setup.py. It's a Python code. And then entry point here. Console script. This line. So Toka equal Toka listener dot Toka node colon main. If I change this name, maybe I need to change this name accordingly, and then save. And then number 8, check setup.cfg, which is right here. This one should be automatically to do this script dir install script script dir base lib Toka listener base lib Toka listener. This is automatically created. Again, this is simply telling setup tools, put your executions in live, because ROS2 run will look for them there. Meaning ROS2 run means I'd like to run a ROS package. There will be a lot of different packages. Let's say I have multiple workspaces. I have ROS2 workspace here, but I have ROS2 underscore something special WS workspace, and then I have to change, right? And then ROS2 underscore run, and then I can identify package name. Then that will start my ROS2 node. Okay, then we are done for now. So let's build. Again, you can go back to this terminal, or you can open a terminal here. So inside this Visual Studio, you can open the terminal here. I just click this. Don't worry about this. You don't have these if you open the terminal, you will see something like this. Okay, and then this one is an optional. The ROS package and then RCLPY and then STD MSG, those packages should be installed already. This ROS DEP means checking dependencies, if these are installed or not. So if I do this, by the way, okay, you could use right the middle mouse button to paste anything I marked, or you can use a keyboard, Control Shift V, not Control V, Control Shift V. Okay, my distro is not Galactic, mine is Foxy, right? So I don't have ROS DEP. Why? Yeah, really? Okay. Interesting. I just somehow I thought I have ROS DEP, but obviously it doesn't have that ROS DEP. Okay, take some time. Okay, I'm assuming, have a RCLPy and STD MSG packages are already installed. I just don't have ROS DEP. So call con and then build. Successful. So one package finish it. I don't know what happened here. Okay, so we are done here. Then source the terminal, meaning here source. This is a command. Install setup bash. Or you can simply put a this dot, same as source. Okay, so what it does is it initialize, it configure my environment, setup. I just created my package, right? That package is not available yet. Before I do this setup.bash, this setup.bash will make my package is available in the ROS2. Okay, and then now if you don't do the source, this ROS2 my package, maybe I can do this. I can close. I create a new terminal here. Again, you don't have to do this. Okay, I built the package and then try to run. It has a Toka listener and then /. This is not my package name. This is a folder name. after install setup dot bash ROS2 run Toka listener, it's automatically find. If your ROS2 run doesn't find your package, most likely you didn't do the source. Okay, so that I can run Toka. If everything was done correctly, this will be our terminal. Something is wrong. Let me see what's wrong. No module named Toka listener Toka node. Toka listener Toka node. What is the right name? Toka listener. Toka node. Toka node. Dot main. Dot main. Yes. Setup. Toka listener Toka node. Did I build right? Yes. No module name Toka listener. Toka listener. Toka listener. What was wrong? Nothing wrong with the code. Something wrong in the.
Just know when you are creating the package, are you in the source folder or you are just in the ROS2 space? Yes, I feel like the Py file probably should be in the same folder as all the setup.py.
Once you build successfully, you don't have to be in that workspace folder. Okay. This is a new thing. We didn't have this one for ROS1. Let me see. Console scripter. No module name. Toka node. Toka listener node. Toka node. Okay, why? Toka node. Let's move it. Okay, let me